Hey math kids, today we're going to talk about the intersection of graphs, and specifically quadratics and lines. So with a quadratic and a linear function, we have three situations. So they call this cutting, which is 2 points of intersection. We have this, which is called touching, which is 1 point of intersection. And then we also have this situation, which is called missing, or no points of intersection. Okay, so those are the three situations that we could have with a quadratic and a linear function. And so let's just do some examples. So what we're going to do, we're going to find the coordinates of the points of intersection of the graphs with, we're given these two functions. Now, I'm going to just show you on Desmos, but then I'm going to show you how to do it without a graphing calculator. Okay, so I typed in those two functions. And we can see this is a situation where it crosses at -3, -6, and 5, 2. So it's the situation where it's called cutting. Now, we're going to do this by hand, is how we're going to do it. And so, algebraically, the way we figure out where two functions cross is we set them equal to each other. Now, we want to get everything onto one side because it's quadratic. And so subtract x, add 3, subtract x, add 3. So we get x squared minus 2x, because these would combine. And then these would make -15, and this side is now 0. So feel free to solve this any way you can without graphing. They actually don't want you to graph on this part. So I'm going to factor it because I think we can. So 1 and 15, 3 and 5, 3 and 5 works if we make a -5. And so we get x plus 3, x minus 5 equals 0, which means we can break it up and set each of those equal to 0. And we subtract 3, so x equals -3. And then we add 5, and x equals 5. Now, those are the two x values of where the functions cross. And if you remember from earlier in the video, we saw that. But what we need to do is we need to plug these into either of the equations and find the y values that correspond to those. Now, this equation is much easier to use, so I'm going to use that one. So y equals -3 minus 3. So I'm plugging in this -3. And so y equals -6. So what that means is that one place where it crosses is -3, -6. Now if we plug in the 5 right here, we get 5 minus 3. So y equals 2. And so we get 5, 2. And if we go back to Desmos, we see we get -3, -6, and 5, 2, just like our algebra showed us. And so that is the correct answer. Okay, now now they give us, now they're going to give us two quadratics. Okay, now they kind of walk you through this one. I don't know why they do it this way, but the first step is to set it equal to each other. On this example, they actually like tell you how to set it up, but I don't think we need that. Okay. Now, it's just a personal preference, but I like to have my leading coefficient positive whenever possible. And so I'm going to move all of this onto this side. So I'm going to minus x squared minus 5x minus 6. Minus x squared minus 5x minus 6. So these become x squared. These become negative 3x. And these become negative 10. And this side is 0. Once again, I'm going to try to factor because I think it'll work. Yep, if I do a negative 5 right there. So I get x plus 2, x minus 5. Now a shortcut with this is we know that we're going to get negative 2 and positive 5. Now those are both, you just change the signs. Now once again, those are x values. Those are not, that's not an ordered pair or anything like that. So we, let's see. So we want to see where they cross. And so I'm just going to plug in a negative 2. The top one looks a little bit easier, so I'll do it there. So negative 2 squared plus 5 times negative 2 plus 6. Negative 2 squared is 4. This one becomes negative 10 plus 6. And so 6 and 4 is 10. 10 minus 10 is 0. So we have negative 2, comma 0 is one of the places they cross. Then I need to plug in a 5 right here. So it's going to be 5 squared plus 5 times 5 plus 6. So that's going to be 25 plus 25 plus 6, which is 56. And so it's 5, comma 56. Okay. Now, on this example, they want us to do a couple different things. So they want us to graph the two curves on the same set of axes. These are where they cross, though. And let's see, what do they want us to do? Graph the two curves on the same pair of axes. So we'll just go to Desmos to do that. So it's x squared plus 5x plus 6. And then we have 2x squared plus 2x minus 4. All right. So we got both of these. We can see where they cross. See, it's the 56 like we had before. Okay, this is kind of hard to see. But let's see what they want us to do next. So now it says solve for the first one is greater than the other one. So we just want to know the two places where they cross. This is really hard to see though. Okay, so if we look at the red one, we see that the red one is higher than the blue one from here until they cross right here. Because if we look at the outside right here, the red is below the blue. For example, if I plugged in this x value, the blue one would give me a higher value than the red one. But if I plug in this x value, the red one will give me a higher value than the blue one. So it just wants to know in between which values is the red one greater than the blue one. And we already have enough information with our algebra, and it's just when we're in between these two values. So the answer to that would be this. So when we're in between those two values, the first one, which was the red one on the graph, is higher than the second one. Okay? All right, we're going to move on. Okay, we are given a linear function, and we're told that it's tangent to this. So tangent just means it touches it. It doesn't cross twice. It just skims the side of it. And so we just need to find k. Okay. Now, what we're going to do is we're just going to go through the process that we've been going through, and we're just going to set them equal to each other, because a tangent is a type of intersection, and so we're still going to follow this same pattern. Now, we want to get everything onto one side, just like we did before, so I'm going to minus 2x and minus k, minus 2x minus k. These become 0. We get 2x squared minus 5x. And then we're going to think of this like one constant because we're assuming k is a constant. Okay. Now, we want the discriminant, so we're going to go back to that lesson. So the discriminant needs to equal 0 because we only want it to cross one time for this function. And so once again, that's b squared minus 4ac. And so we're going to think of this entire thing as our c, and then this is our b, and this is our a. So we get negative 5 squared minus 4 times 2 times 4 minus k. All right, so we get 25 minus 8 times 4 minus k. So we'll need to distribute that negative 8. And so we get negative 32 plus 8k. Then we still have this 25. If we combine those, we get negative 7 plus 8k. And we set the discriminant equal to 0, right? Because there's that. And we just add 7. 8k equals 7. Divide by 8. Divide by 8. So k is equal to 7/8. So if we set k equal to 7/8, meaning this becomes 2x plus 7/8, then these two will be tangent. And so let's just look at that to double check that that really is true. So we have 2x plus 7/8, and then we have 2x squared minus 3x plus 4. Then we see right there, it really does just skim it. See how it's tangent right there and it just skims it. So, yeah, that plays out. Okay, that's all for this section. If you need additional help, please come to Math Lab. Until then, calculator.